Okay. You know what? This is not the same as what you use in real life English. If I asked you to name a strong chemical, tell me what you think a strong chemical would do.
Smell.
Smell? Hurt you if it got on you? And another synonym for a strong chemical would be toxic, dangerous,
Poisonous.
poisonous, hazardous, concentrated. It's not what it means in chemistry talk at all. Strong and weak have to do with the way something dissociates. Define dissociate. Yep, dissociate is the same as breaking apart. Chemists are big, giant fans of synonyms. Another word for dissociate is to ionize. Ionize means to break apart into ions. Ions. A strong acid or a strong base completely ionize, completely break apart. If you had hydrochloric acid, which is a solution, so you put the hydrogen chloride gas into the water, it would completely break into its ions, like that. Now, there are only 6 strong acids that we're going to talk about. Just 6 strong acids. It's on you to memorize them. They are this one, name it. Ooh, off to a great start. Let's back up 1 minute. Is this binary or ternary? Ternary. So does it qualify for the hybrid rule?
No.
No. So you better be looking on your green sheet of happiness and find the polyatomic ion that it is made from. It is nitrate ion, so the acid is nitric. All right, now that we warmed you up a little bit, what is this one? Sulfuric acid. This one, binary, ternary?
Binary.
Binary, so it's hybrid, so it starts with
Bromide.
hydrobromic.
Oh.
All acids tend to end in
Hydrochloric acid.
hydrochloric acid. This is hard to pronounce, but give it a roll. Oh, nice job. Hydroiodic acid. Find this one. Perchloric acid is correct. There's a memory hook. Would you like it?
Yes.
Yeah.
Okay. No. Sober. Class. Clowns. In Hawaii.
No sober class clowns in Hawaii.
No. Sober. Class clowns in Hawaii. All the class clowns in Hawaii are very jolly. No, sober means somber. Sober means that they don't smile a lot. No sober class clowns in Hawaii. Write that down. You'll be in college and you'll ask your lab partner, hey, what are the strong acids? And your lab partner will go, no sober class clowns in Hawaii. Or sometimes they say, in Idaho, but I don't know why you do that. I'd much rather be in Hawaii. So, if it's not one of those 6 strong acids, it is a weak acid that either do not dissociate or dissociate just a little bit. What's a strong base? Well, let us define it. A strong base is a alkali metal bonded 2 hydroxide. The hydroxide ion. So, name this. Potassium hydroxide. Is it going to ionize completely? Because it is a strong base. I don't know what that was, plus. Strong or weak? Weak. All right, here's a depiction of a strong acid. Give me, pick a strong acid for me.
Hydrochloric.
Okay, not hydrochloric, because we use hydrochloric all the time. Name a different one. Hydroiodic. Hydroiodic. If you put hydroiodic acid, the gas, and bubbled it through and made the acid would break apart. Here would be the iodines, and here would be the hydrogen ions. Would this conduct electricity?
No. Wait, yes.
Yes, it would. Yes, it would. It would conduct electricity because you need ions to conduct electricity. Why are ions made? Ions are made when electrons move around. Here's a weak acid. Name a weak acid. You might have to go to the first page of your notes.
Anything that's also with
Yep, I need one.
Sulfate.
Acetic acid. Acetic acid is found in
Vinegar.
vinegar. When you put the acetic acid does not ionize. These particles stay bonded together like that. Will this conduct electricity?
No.
Nope. Nope, will not. Alright, so here you go. A strong acid, hydrochloric, completely dissociates. A weak acid, name this acid. Hydrofluoric acid only partially dissociates. Just a few particles of HF will break down into the, what do you call this thing? What's its name?
Oh, proton.
Yep, it's either a proton or the other word for it is a
Hydrogen
ion. Okay, a strong base in solution will also completely break apart. This one will or will not conduct.
Will.
It will conduct. This is a weak base. Name this base.
Nitrogen.
I saw somebody look on their star chart, perfect place to look, because these are both polyatomic ions. 2 polyatomic ions. All you do is say their names. So this
Ammonium
would
hydroxide?
be ammonium hydroxide. It is a weak base. Does it conduct?
No.
It is non-conductor. All right, ladies and gentlemen. Whoa. This is an ugly old problem. Let's see if you can walk through this ugly old problem with me. All right. Ionization means to break apart. Stoichiometry was the skill you learned. It's terrible. Was the skill you learned last unit, and you used those boxes, correct? Okay, now we know where we're starting from. The question asks, how many hydrogen ions will be produced by the dissociation of 6.49 grams of, name that acid? Sulfuric acid. What is the first thing you need to do any stoichiometry problem?
You need to state the given and down here.
Balance the equation. So now you have to make up an equation. What is the reactant in this equation? Sulfuric acid. Any other? We know it's in water. Okay, and how does it break apart? What are the products when it breaks apart?
Well, hydrogen ions.
Hydrogen ions and
SO4.
Sulfate ions. What's the charge of the sulfate ion?
-2.
-2. Is this balanced?
No.
How would I balance it? 2 in front of, okay, good start. Now, we need to put our given and our unknown. Our given is
6.49 grams.
6.49 grams of the sulfuric acid. What do we want to know? What's our X?
How many ions will be
Less
produced?
hydrogen ion.
The number of ions. Alrighty here, so I have the makings of a box, don't I? I think I'll start with a mole ratio because that's always helpful. My mole ratio is now, I see grams here, so I'm going to guess I'm going to need a mass ratio, correct? Let me see, H2SO4. It has H's, S's, and O's. 2 H's, 1 S, 4 O's. H are 1, S are 32, O's are 16. By the power of math, I know that's 98 grams. 98 grams. A mass ratio is the molar mass times the
Coefficient.
which is
1.
98 times 1 is
98.
98. All right. So here I have 2 hydrogens that have lost an electron. A regular hydrogen atom has a mass of 1. Oops. That's kind of weird. I don't want you to go away. Okay, thank you. Of 1. How much does an electron weigh? Almost nothing. Can we just ignore the electron's mass? Okay. So the hydrogen atom is 1. Its coefficient is 2. The mass ratio here is
2 grams.
2 grams. Hey, if this was 98, this minus the hydrogens is going to be
96.
96. All right. Now, I need one more ratio. What is that ratio going to be? Particle ratio. I could call it the particle ratio, or I could call it the ion ratio. Either one. They're both using Avogadro's number times the coefficient. So this would be 6.02 times 10 to the 23rd particles. These are ions, so we would use the ion ratio here, which would be 2 times Avogadro's number, 1.02 times 10 to the 24th ions. And this would be 6.02 times 10 to the 23rd ions. Everybody with me so far? Now, I just need to make a ratio. 6.49 grams of H2SO4 What goes on the bottom of, what's the denominator here? 98 grams is equal to how many ions of hydrogen, and what goes in the denominator here? 1.20 times 10 to the 24th ions. Because you remember, you need your units to be the same. You would cross multiply, and who is going to supply me with the answer? Cross multiply and divide. Everyone's using their calculator because they're very happy to have it. Who's the brave soul who wants to yell out what it is?
6.75 times 10 to the 22.
I will agree with the times 10 to the 22.
At least I'm brave.
7.97. 7.97 times 10 to the 22nd ions. Did you get 8 point something? Same number. Same point.
Oh, I see.
That's 1.94.
Okay. All righty. Moving on. That was an AP type problem. That was a trickalicious stoichiometry problem. Good for y'all. Hung in there. Okay, now, I want, before you write anything down, okay, write down and then I'll talk about it. I'll just walk around and look outside. I think it's gonna rain. Finished writing it? I need you to remember something from a previous unit. A solution is composed of two things. Tell me one thing. Solute
And a solvent.
and the solvent. Now, how many people have seen or actually use that Mio stuff? Mio? Do you know what that is? How do you say it? Mio? And so it is a flavoring, right? Okay, and you put it into your water bottle. If I took the entire thing of Mio and put it into a standard 12-ounce water bottle, would I have a concentrated or dilute solution? Very concentrated, and now please use chemistry terms, because I've added a lot of which component of the solution? I added a lot of solute, didn't I? A lot of solute. Okay, does it mix all together, right?
No.
Yeah, you shake it up and it mixes together. Can I, after I made that really concentrated, lots of solute solution, and I tasted it and I decided it was a tad too intense, could I take some of the solute out? If I wanted it to be more dilute, what would I do? I would add more, tell me the chemistry term, I would add more solvent, wouldn't I? Okay. That's kind of weird. Here we go, just moving on. Could you tell me what this unit means?
Molarity.
It is molarity. Would you look on your star chart, please, and tell me what molarity is defined as?
Moles of
Equals
solute.
moles of solute over a liter of solution.
Moles of solute over liters of solution. And we have discovered, or we remembered that a solution is a solute plus a solvent. A concentrated acid has a lot of moles of solute. A dilute acid has lots of a little mole of solute. Do you get that? Can you have a concentrated weak acid?
Yes.
Are you sure?
No.
A concentrated weak acid. Name a weak acid. Vinegar. Vinegar.
Yeah.
Okay. If it is concentrated, okay, in vinegar, if we remember, is the acid in water, yeah? An aqueous solution. So vinegar is weak because it doesn't do what? It doesn't dissociate or break apart. Could we add lots and lots of moles of this in a little bit of water and it would be concentrated? Yeah, that'll work. So if you have more moles per liter, that would make it concentrated than if you had less moles per liter, that would make it dilute. All right. Fill in your blanks, do a little math. Fill in all the blanks? Did you do the math? Okay, ladies and gentlemen. You know, when we need to use chemicals in here, you know, on Tuesday we did the acid-base station lab. What was the acid that we used? Hydrochloric acid. When I buy hydrochloric acid, in fact, I just bought unpacked a jug of hydrochloric acid today. It comes in a glass bottle about this big. It's wrapped, it has a protective layer of wax on the outside. It's wrapped in styrofoam, and then it's put into a bottle, into a box with a bunch of packing popcorn peanuts. Why do you think? What would happen if it break? Okay, why would you be nervous if it broke? Is it
Dangerous.
strong or is it concentrated? Are you worried about it being strong or are you worried about it being concentrated?
Strong. Concentrated.
Allegedly, you're worried about it being concentrated. It is a strong acid. It will dissociate completely, correct?
Correct.
But if I diluted it enough, would I be able to drink it? Yeah, you do all the time.
What?
What? How do they clean the water? They put a little chlorine in it. Oh my goodness.
No, it's
So if you diluted it, if it was dilute enough, it would be okay, even though it's a strong acid. Because remember, the solution to any pollution is dilution. So if I just added a lot of solvent, it'd be fine, you'd be okay. However, the jug that I buy is use a chemistry term,
Concentrated.
concentrated. Very concentrated. I am not, when I open the bottle, there's so much solute in the solvent. What's the solute? HCl. So much. It's totally saturated. What does that mean? It cannot hold anymore. It cannot hold anymore. And when I uncork it, hydrogen chloride is a gas. I can see the gas coming out of the bottle. Yeah, you know what? It's kind of scary. I'm not gonna lie to you. It smells really like I don't think I should breathe it when I open it up. I always do it under the hood because I'm not a dummy. All right. So anyway, am I just gonna pour that into a beaker and say have fun?
Absolutely.
Absolutely not. Absolutely not. The bottle is 12 molar. 12 molar. That's totally as concentrated as can get. What concentration do you use for your lab? Does anybody know?
7.
8.
Point something.
Okay, these first 3 stations used 0.1. 0.1. The conductivity and 4 and 5 used 1 molar. How did I get the 12 molar to become 1 molar? I added solvent, and the word for that is I diluted it. The most useful equation to everyday chemists, and you do this too when you might not know it, when you're making your Mio drink or when you're making, when you're adding Crystal Light to your water, is how to dilute something. I need to be able to precisely figure out how much of everything I used. So here is the equation we use. M1V1 equals M2V2. I like the M's in front. I don't know why. Yes.
Is the V in liters or milliliters?
Ooh, excellent question. Hang on for a minute and I will define it. First of all, let us write what M1 is. M1 is always going to be the most concentrated and it is what you start with. M2 is going to be the least concentrated,
What you mean?
and what you end up with. Okay, V1 is the liters, there's the answer to your question, of the most concentrated. And V2 is going to be the liters of the least concentrated. The whole trick to these problems is defining your variables, making sure you know which number goes where.
Like V2 is what
You have a question? All right, here's a practice problem for us. What volume of 2 molar sulfuric acid would you need to prepare 100 milliliters of 0.4 molar sulfuric acid? Okay, we're going to define our terms first. What is this?
That's N1.
It's going to be M1. How did you know?
Because what you start with.
It's what you start with and it's the most concentrated. All right, so then this must be
N2.
M2.
M2. We have a volume here, let's see. Prepare 100 milliliters of 0.4 molars. So this volume belongs to M1 or M2?
N2.
M2, so this is V2. So what is our X? V1. V1. So if I were going to do this, M1V1 equals M2V2, why do I say it that way? I don't know, that's the way I learned it. I would do 2.0 times x is equal to 0.4 times 0.1. Where did 0.1 come from? I converted milliliters to liters by dividing by 1,000. X is equal to 0.02 of H2SO4? We have two H2SO4s. Which one?
And one.
2
Or
molar. Yeah, 2 molar H2SO4. 2 molar H2SO4. Okay, now I want you to think about this, please. All right. I have two containers. I have my original one, M1. That's great, in my flask, isn't it? I have 2.0 molar H2SO4. And then my other Erlenmeyer has what I just made, which was the 0.4 molar H2SO4. Here's the question. Which one, or can I use both, could I make 1 molar H2SO4? Can I make 1 molar